Okay. So can we go ahead?
Yes, please. We can see the screen.
Okay. You see the screen?
Yes, we can see it.
Okay.
Yes, please. We can continue.
Okay, thank you.
Yeah, we can see it.
So today we'll be looking at networking concept. This chapter is also important, very important in the sense that some of us will be proceeding with the CCNA package. So there's a need for us to align ourselves with some of the concepts here. So that once we start the CCNA class, I don't think it will be much of a problem because some of these things will come as add-on for us. So we'll be looking at some of the basic concepts in networking. And alongside the objective of this course is we look at network components and types. We look at computer networks, describe the types of networks. We also look at network internet connection types. We also look at network protocol standards and services. We'll be explaining these under the headlines of network protocols, standard services, purpose and characteristics of transport layer protocols, the significance of application port numbers. Looking at wireless, we'll also explain network services. Okay, and then we'll look at the purpose of device on the network, basic network devices, security devices, network, explain other network devices. Alongside, we'll be talking about network cables, looking at the characteristics of network cables, network tools and their purpose, the purpose and characteristics of common types of copper network cables and connectors. We'll also look at the purpose and characteristics of common types of fiber network types of and connectors. Kindly mute your mic, please. So network components and types. So if you look at the network components here, to your left, look at the icons. Some of the icons that we're going to be working on the simulator, which is the packet tracer. Cisco has a simulator you use to design a basic network, an advanced network, and also help in configuration of this network. And so it's important to get used to some of these icons that represent the switch, routers, and the other intermediary devices. So basically, this is a switch. This is the icon of the switch. But in real life, it's a little bit different from what you can see here. But that notwithstanding, I want to believe I have a live Cisco router switches that can also show us. That will be the next class of the office. I'll get that across. Okay, so this is a switch, and this is a router, and this is an access point. This is a wireless router, and this is a modem. And all these are referred to as intermediary devices. In other words, they provide that connection between the source device and the end device. The source device could be a laptop, the end device could be a printer, it could be another laptop, and all of that. So the network components or devices that aid the communication between end devices are referred to as intermediary devices because they come at the the intermediate between the end devices. So they are referred to as intermediary devices. So we also have network media. In other words, if communication must take place, you need some kind of media or medium that will aid connectivity. So here we have the media icons. For a LAN, a typical LAN, which is local area network, it's a straight through cable. And for WAN, which is wide area network, this is the connection we have. And for wireless media, this is the connection we have. And then for network cloud, this is the connection here. So each of these icons tells you whether you're dealing with a LAN, with a WAN, with a wireless, or network cloud. So that once I take you to the packet tracer and I begin to bring out some of this media, you won't get confused about that. To the right, you can see desktop computer. These are like end devices, or what we call host devices. This is a laptop, this is a server. You can see a tablet, smartphone, printer, camera, IP phone, scanner. And then network topology and description. When we talk about the network topology, and you're looking at the description, you'll see here we have what we call the PAN. The PAN is the personal area network. Okay? The PAN is a personal area network where you just have a single individual having his Bluetooth, his wireless keyboard, wireless mouse, and you have your printer, wireless printer, all connected for the purpose of sharing resources. Is referred to as what we call PAN, personal area network. It looks like one of the smallest network type you can ever imagine. Okay, and then we have the LAN. Most of us are familiar with LAN, which is the local area network. So it's a wired network consisting of switch and network devices in a limited geographical area. That means it's within a geographical area. And then if you look at it critically, it is wired, so it must be cabled in this sense for it to be LAN. If it's not cabled, then it's wireless. Then we have what we call the VLAN. The VLAN, or what we call the virtual LAN, extend beyond a traditional LAN and group users based on administratively defined boundaries, such as department or floor. So the VLAN is actually a LAN that has been further subdivided with the aim of creating a new domain, like new domains for the entire layout. For instance, you have 500 computers connected to a typical LAN network. You might discover here that maybe in the future, as we go on with this class, a typical switch is a broadcast domain. In other words, for it to operate, it has to broadcast. And when you have about 500 computers connected to that switch or connected to the LAN network, there's bound to be a broadcast tone, which of course will lead to what we call congestion, and afterwards leads to slow down in the network performance. So it is necessary that this whole design that will accommodate 500 computers on a typical LAN connection be subdivided into what we call domains, and these domains are referred to as VLANs. And the aim is to break the broadcast domain so that you have some kind of administrative control for security purpose, or what we also call manageability. So that's what the VLAN actually represents. So it goes beyond the traditional LAN, we all know. And then the wireless LAN, which connects multiple wireless devices and uses an access point. So you can see multiple devices connected here, and then you can see the access point. So there's a difference between a typical Cisco router and the wireless access point. The wireless access point has an extra node. You can see with an extension here, like an antenna, which it helps to distribute or receive signals. Okay. So network topologies in description. Wireless mesh network. So you can see beyond the normal LAN, we have a wireless mesh. In other words, you have a wireless network which is meshed to expand the wireless network such that you don't have like wireless network just within a room or maybe within a hall. You can actually extend it to other areas. And then we have the MAN, which is the metropolitan area network, a network that spans a city. So the MAN is also referred to as a city network, where it's just within the city. And then the wireless access, the wide area network is a network that spans a large geographical area. So we did said that the LAN is within a geographical area, but in the case of the WAN is actually expands. One spans a large geographical area. I mean, it's across geographical areas. So you can see it wide area network. So you can see in the design to your right, you can see the LAN, two different LANs connected by what we call the internet. Then we have what we call the VPN. The VPN is a virtual private network. It's a method of connecting the network such as a company network across an unsecured network. The internet, we all know, is not that secure. So for you to create a connectivity between two end enterprise or two end networks, you can actually use VPN. So VPN provide that security on an unsecured network. An example is the internet. So brief history of connection technologies is we have what we call the analog, which is more or less the traditional kind of network, internet design, network design. It uses an analog modem to call another modem. So that's what we know like a dial-up. And then we have the ISDN, which is Integrated Service Digital Network, more bandwidth than dial-up, can carry voice, video, and data. Okay, so we have the broadband. We have the broadband uses different frequencies to send multiple signals over a media. So we can see here the satellite receiver, we can see the DSL modem, and then we can also see the cable modem, just to buttress the point here. And the DSL, what does it stand for? The digital subscriber line, always on a technology that uses phone lines, voice and data. In other words, a unified internet connection type. It requires a filter on the port that connects to a phone. And so this is how the design is. So you can see it more or less like a packet switching network. You can see the router here, you can see the modem here, so there's a connection between these two. And then look at here, we have the cable. The cable uses a cable modem to connect to a traditional cable TV network, shares the network with multiple subscribers. So this is another form of internet distribution or types of internet connection. And so we have the fiber. The fiber is high bandwidth connection used in backbone networks, large enterprise environments, large data centers, and now part of some home internet connections. So that's the fiber for you. So the fiber is high bandwidth, high speed, because the fiber transmits with what we call light. And we all know the speed of light. The speed of light is about 3 times 10 to the power of 8 meter per second. So you're looking at about 300,000 kilometers per second. That's the speed of light, which of course fiber operates on too. So you can imagine that speed in which the signals travel in a single fiber connection. Okay. Line of sight wireless internet service. So line of sight wireless always in technology that uses radio signals for connecting to the internet. So clear path must be required. And oftentimes with these, you sometimes use dish to make sure there's a line of sight. Line of sight means that you must be on the right frequency of transmission. So sometimes you have to tilt the antenna on the radio such that you be on the same track. We also call that a clear path required, whether affect signal strength and performance in this kind of radio signal transmission. So that's what we call a line of sight. And so you can see satellite here connection. It's a broadband technology for remote access. It uses a satellite dish. Not a good solution for time-sensitive applications like gaming, voice over internet protocol, and video conferencing. The reason why this is hit against in the sense that if you're doing video gaming, it's quite high bandwidth, and if you're using this form of transmission, you're going to have some losses in the cost of transmission. So not a good one, because you're sure to have kind of slow speed when you do gaming, voice over internet, and video at the same time. These are high bandwidth contention applications, so that will actually slow down the speed of the internet. So for cellular, mobile internet connection type relies on cell towers to create a network used by cell phones and connectivity to the internet. This is another form of internet, which is common, which all of us are actually enjoying today. And then mobile hotspot and techno. You can create hotspot with your phone. You can also allow other devices to connect to your internet using the Wi-Fi. You can use Bluetooth or USB. So these are some of the stuff you could do by creating a hotspot. And then the other device is using the phone cellular connection to connect to the internet, called a tethering or a hotspot. A mobile hotspot is when a cell phone allows Wi-Fi devices to connect and use the mobile data network. So you already have an existing network on the phone, and then you want to create a field. You want to create a field effect where internet network actually reside. So once you actually tethering that whole Wi-Fi on your phone, you create that whole connection network name, which will be available for as many that wants to connect, and usually it's within the region of space where they can actually access it. So we refer to that as a hotspot, because you're providing some form of internet connection. So from one single phone, more than 4 or 5 persons can connect and browse on the internet. So it's also a mode of, it's also what called internet types of network. So networking protocols, we'll talk about standards and services. So there's a video for you to watch, which helps to talk about the protocols, the standard, and when it comes to networking, there are a lot of protocols that actually guide different steps and approaches to the network. So we'll be looking at TCP, UDP, and sequence numbers. So if you watch the video, you don't really come across this. The TCP is the transmission control protocol. The UDP is the user datagram protocol, and the sequence numbers. So the TCP/IP model application is FTP, the HTTP. Remember, the FTP is the file transfer protocol. The HTTP is what we call the hypertext transfer protocol. The SMTP is for emailing, which is the simple mail transfer protocol. DNS, which is domain name service, and the TFTP, which is a tribal file transfer protocol. Now, these are all actually on the application layer. We're looking at the TCP/IP model. Remember, here we're looking at network protocols. The network protocol here is that we want to look at models that actually describe the protocol of the network. And one of them is actually the TCP/IP model. So you can see that here. You see the transport down here. So in other words, for the TCP/IP model, it is divided into 4 layers. And what are they? Application, transport, internet, and network access. This was put together by the US military, the Department of Defense, and the aim is actually to see how resources can be shared from one point to the other. And so the transport layer here is the TCP and also the UDP. So the TCP is the transmission control protocol. The UDP, like I said, is the user datagram protocol. This TCP is actually meant for real-time transmission when it comes to your normal data use that on TCP. But if you want to do voice, video on the internet, it goes through your UDP. So these are two pathways. One of them is actually your normal text messages, your normal messages. But once it involves voice and video, it's routed through the UDP. That's why you can see the UDP and TCP all on a transport layer. And then the internet is the IP itself. Okay, so the internet layer is an IP. And then network access. Network access has to do with LAN connections, and then WAN connection. So TCP and the UDP. Okay. So the TCP example is the SMTP, POP, which is for email, and then the HTTP, which is a hypertext transfer protocol. Then for voice and video, you can see the IP phone. You're streaming live video on the internet. So once you're streaming live video, you're actually using the UDP mode of the transport layer. And so for the TCP, it requires protocols properties such as what we call it is reliable, acknowledges data, to send lost data, deliver data in sequence order. And so when you're using the TCP, you're sure that it's actually reliable and then there must be an acknowledgement. So when you send a mail, for instance, you get message sent, more or less an acknowledgement to show that it has been delivered. And then resend lost data. Should for any reason there's loss of data in the course of transmission, it will be sent because the job of the transport layer is to maintain what we call end-to-end data integrity. And so you're sure to see it resend and then deliver data in sequence order. So this is actually arranged in sequence order or a TCP. Then the UDP actually requires protocol properties which are fast, low overhead, does not require acknowledgement. There's no acknowledgement in the UDP. That's the reason why when you actually listen to music on the internet, and for any reason there's a distortion on the internet or probably one of the issues, you're sure that they will disconnect on that audio or video as the case may be. So it won't resend, like in the case of TCP. It will also acknowledge, so it is connectionless. That's the difference between the two. And then the network, the IP, which is the internet, and then the network access, which is your LAN connection and your wide area connection. Then the TCP actually has three basic operations of reliability. One of them is the numbering and tracking of data segments. And two is acknowledgement of received data. So transmitting any unacknowledged data after a period of time. So it waits after a period of time and try to retransmit. Reason being that the transport transmission control protocol try to see that it actually ensure that information is carried from the source is delivered at the destination. Okay. Then this is the UDP. We've also explained the UDP, but very little overhead on data checking. It's best effort delivery protocol that's unreliable in the sense that it cannot guarantee you transmission to the destination. Because sometimes some of these packets are corrupt in one or two ways, and because it does not retransmit, it does not acknowledge, there's no way that you can actually get to hear that person again from the phone, an IP phone, and also in the case of a video, you may not be able to watch that part again. Okay, except to start the entire communication flow. So no acknowledgement that the data is received by the destination. So there's no acknowledgement when it comes to the UDP. So you need to watch the video to understand the source, destination, well-known port. So classify application port numbers. So we have applications that actually are classified and actually get kind of dedicated for certain applications. An example is port 53. Port 53 is actually the DNS, port number. This port number we're talking about has to be the services. There are different services that take place on the internet, your services that have to do with file transfer, which is perhaps at the FTP. We have services also. It's also referred to as HTTP for browsing the web and surfing the internet, which is on port 80. For HTTPS is on port 443, which is the secure part of the HTTP. And so these are actually different services, and they must run in different ports. And port 80, like I said, is HTTP. Port 443 is the HTTPS. Then port 25 is SMTP. So if you look at this port transport protocol, application protocol, and the description, so you can see here that the domain name service protocol finds the IP address. So in other words, telling you that the DNS job is to resolve the IP address. So remember, if one or more devices must communicate on the internet, there must be a DNS. The DNS that finds the IP address can help you to resolve the domain name. So it's very, very important. And then port 80, like I said, provides a set of rules for exchanging data, graphic images, sound, video, and other multimedia files on the wide web. So that's why each time you want to watch some videos on YouTube, the first thing you must launch your browser. And the browser gives you the ability to be able to have access to different sites. So that's actually the importance of the HTTP. And we have the HTTPS, which is secure. And so also, to identify email, identify main protocols, we have the port 25, which is SMTP, port 110, which is referred to as port office protocol. And then we have the IMAP, which is the Internet Message Access Protocol. And then we have the LDAP. Now, these are all existing protocols. These protocols actually are for email and management protocols. And then these are the port numbers. So we refer to these port numbers as well-known port numbers. Because once you block any of these ports, you're sure that the services will not be available. So, classify application port numbers. These are application port numbers actually classified. So, port 67/68 is for the UDP and your DHCP. And then from 137 to 139 to the UDP and TCP. And then we have the SMP, which you said also 161/162. These are a range of port numbers. So 427 is also UDP and TCP. And then these are the descriptions of their services that run. So at this level, it's expected that you get to familiarize yourself with the well port numbers against other port numbers, because there are some of the port numbers that are actually private port numbers, which actually are dedicated for some special application. So the file transfer, the file transport and management protocol. If you look at it here, we have port 20, 21, 69, 445, 548. And then if you look at the transport layer, you see that some of them operate under the TCP and some under the UDP. But the application protocol here for each of them is specified. Your port 20 and 21 is on FTP. So FTP uses port 20 and 21. Remember, you are either sending or you're receiving, whether downloading or you're uploading. So what we're saying here is that when you're doing use for transfer of files between computers, once you're doing that transfer of files, it says you're using port 20, and when you're doing receiving, you're using port 21. So please, I want us to get used to all these port numbers and their services. So for the wireless LAN protocols, we have it as 802.11. So the 802.11 is of the wireless protocol. Then we now have them in A, B, G, C, N, N, A, C, as the case may be. So these are like some of the wireless standards by IEEE. So maximum speed is that you have it 4 Mbps, 11 Mbps. So if you're using the standard of IEEE of 802.11, the maximum speed you get is 54 Mbps. And then if you now use any of the equipment, wireless equipment that of 802 or 11B, you get a speed of 11 Bps. And now you can see the difference. Okay, so when you use any wireless device that's designed based on the IEEE standard of 802.11ac, you have a speed approximately to 1.3 gigabytes per second. So that's a good speed to actually transmit at 1.3 gigabit per second. Okay. Many years back, we were struggling with the 802.11b and G, but today we have super speed on the wireless network. So this is the maximum indoor range. This is the frequency of transmission, and then this is the backward compatible. So we have new devices that are also backward compatible with the legacy wireless network. So wireless Bluetooth, we have the wireless protocols. We have example Bluetooth, NFC, and RFID, and then which is radio frequency identifier, and then identification. Then you have Bluetooth. Bluetooth, which actually take up to 7 devices to create a PAN, and then 802.15, which is also still part of Bluetooth technology, and then 2.4 to 2.4 gigahertz radio frequency range 2, still fall in the Bluetooth frequency range. Then the RFID is a massive or active tags used to identify items such as passive and active. So when it's passive, it's rely on the RFID reader to actually activate and read. And when it's active, have a battery to broadcast the ID up to 100 meters. So if you look at some of these stores, you actually use RFID for security reasons. You know, they embed these things oftentimes in the food. So once the customer picks it up and it's probably without paying, the alarm triggered. So it's actually used for security purposes as well. And then it's of 125 megahertz to 960 megahertz radio frequency range. And then the NFC, which is the near field communication, devices must be in close proximity to exchange data. So you can see here, for the wireless technology under the NFC, that these devices will actually be at a very close range, used for payment, printing, public parking, and all of that. So that's actually helped in taking care of this aspect of the job. And so here is what we call the ZigBee and Z-Wave. So the ZigBee requires a ZigBee coordinator to manage client devices connected in the wireless mesh network. So you can see here that you need an extra device to manage the different clients that are connected to the wireless network. So devices commonly managed from a cell phone. It's actually being managed from a cell phone. The IEEE 802.15.4 is the standard, which is still Bluetooth. And then 868 megahertz to 2.4 gigahertz range up to 20 meters. So that's the standard for it. And then 65,000 devices, which is quite much. And then data speed is up to 250 kilobits per second. So the Z-Wave proprietary standard, a public version available for the Z-Wave, and then the two device can connect to the wireless mesh of this wireless protocol and network with data speed of up to 100 kbps. So the cellular generations actually have come a long way from the era where we actually have the first 1G, 2G, 2.5G, and all this has to do with the speed in the network. So now we're in the era where we're talking about 5G, and all this is how best the wireless protocol can actually speed up. And so we can see here that each of them has its speed, and then look at the 5G. The 5G has a speed of up about 3 gigabits per second, which is very, very fast. Okay. So these are the different types of wireless generations we have, and then their speed, their corresponding speed. And so further, for you to go further into the network services, there's a video for you to watch on the data card, which is DCP, dynamic host configuration, and then what the DNS, and then the HTTP to see how this works. Okay. This is a client server rules. Client server rules is where you have the different types of activities housed in different systems or servers, and then you have one central server that will help to control the others. So email client and server. So these are different types of network services under client and server rules. Remember, the client will initiate request and the server will respond to request. This is DHCP server that provides IP address information. And for DHCP server, it's actually it's automatic. It's automatic in the sense that you don't manually configure the device. And then the DNS server translates the domain name. I've earlier said this, such as cisco.com to an IP address. So cisco.com that you type on your URL is not, it's a domain name, but it has an IP address which helps to resolve that domain name. And so cisco.com IP address, for instance, is 198.133.219.25. So that this is a private IP address that has been designed for Cisco. So once you type 198.133 for 219.25 on URL, it's meant to open up the Cisco web page. So this is a print server that actually provide control multiple printers so that you can print from some set of printers. So it becomes like a gateway. Okay. So a file server allows clients to access files using a specific protocol. So you can also demonstrate a file server where all the files that are needed in the organization are actually populated there. So some of us can actually free our system. So this is the web server. We explained this that the port HTTP is for your that's port 80 and HTTPS is for that's port 443. So this is still the mail server, proxy server for proximity sake, because oftentimes if you send a message on the internet, it goes on a round trip, from when to get to the destination and when the feedback comes. So there's some kind of delay along the way. So the proxy server helps to intermediate between the main server and the client device, because the main server might be doing a lot of things. So they need to create proxy servers. So proxy servers aid operations in the sense that the information that is meant to be in the original server is actually shared with proxy server. So on the education server, we have servers that actually for education with authorization, accounting, and allow access to a network device or a particular network. So the client establishes a protocol with the router, then the authorization, accounting, actually, which is router prompt the user for username and all of that. So when it prompts the user for username, and then the user actually responds, so the router authenticates the username and password using a remote AA server. And so this actually is to create that check, and it's also part of the network service. Okay. And then we have the syslog for logging different activities that happen with the network. So the syslog shares network messages sent by network devices. Okay. So let's look at some basic network devices, the switches and the routers. So today's computers have wired or wireless. So you can see the two. One is internet and the one that is wireless. The one that is internet is a port gallery, and then the one that is wireless is no port, it's an internet. And then you have a USB in case you want to copy some stuff. So this is actually some of the computers wired or wireless network capability. So we have other network devices. For instance, repeaters, bridges, and hubs. So the repeaters also called extenders because they regenerate the signal so it can be sent further. That's the repeaters. And the hub receives data on one port and send to all other ports. So when you talk about repeaters actually help to send the signal. Hub receive data on one port and send to all other ports. The hub does not actually interpret the signal, so it just propagates the signal. An example of a hub, we actually have devices that are hubs, and they look like switches, but because they don't interpret signals, they just propagate the signals. So they are referred to as hub on the network. And then we have the bridge. The bridge actually meant to the bridge divides the network into two or more segments and then attacks which device is on each segment. So once they are connected, it will begin to look at which device is actually is a problem on the network. So that's for bridging. So it bridges one or more networks. And this is the switch. So like I said earlier, the switch is a network device. The switch actually record MAC addresses. It has what we call a MAC table or a CAM table, where all the addresses of all the people that are browsing on that network are kept. So you have the MAC address actually saved inside the switches. But once the system is shut down, restarted, when it all goes start, as you go start the entire switch, all the MAC address will be lost. It's actually not a permanent memory that keeps the record for a longer time or lifetime. So wireless access point provide access to a wireless network for a limited range. And then the routers use an IP address to forward traffic to the network. So what the router does is to route information from point A to point B and all of that. So the need for us to watch the video on the firewall, to the router, ACL, IDS, and IPS are very important. When you watch the video, it gives you also more information. And so what is, hello, can we hear me? Hello, are we there?
Yeah, we can hear.
Oh, fine. So we also okay, thank you very much. So we also have security devices. Security devices, example is the firewall. So you can see where the firewall is located between the external switch and then the internal router. So a firewall protects data and devices connected to a network. Firewall uses access control, what we call ACL, which are rules used to determine whether data is permitted or allowed in network. So you can actually permit certain systems, deny certain systems. So you either permit or you deny. That's actually the two language here when it comes to ACL. So some written policies that helps to direct how traffic route into the network and how route traffic are being selected. So we have a firewall, you can decide which is which. And so this is the IDS, which is an intrusion detection system, which monitors traffic, and it's a very passive system. And then we have the IPS, which is intrusion preventive system, actually monitors traffic and takes action when needed. So there's a difference between one is passive one takes immediate action. So this is a typical example of a firewall. Okay. And then the UTMS, which is the um, universal threat management (UTP), is an all-in-one security appliances. Features are vendor-specific, but could include the normal firewall services, IDS, IVS services, all integrated. And if you look at it here, it provides additional security services at 0-day denial of service. These are some of the attacks that you can actually overcome using this. Okay, so we can see the device. They are actually of different series. So the security devices. So we're looking at endpoint management server. So an endpoint management server monitors end devices such as a PC, laptop, servers, and tablet. That's the endpoint management server. Okay. Okay. So other network devices with legacy and embedded system. So a legacy system is a device on the network no longer supported but still in operation. So once you have some of these old devices, you can see that there's no support, so we refer to them as legacy because once in a while they reach the end of life for one or two reasons. So once there's no support, we refer to a legacy. So an embedded system is a device built into something else, such as appliances. Embedded microchips are contained in legacy systems and embedded systems. So legacy systems and embedded systems could be a security risk because they're legacy, and for one or two reasons, the time when they are created, security might actually be an issue. So this is a patch panel for linking different networks. You can see the PVC cable terminated on the patch panel. In big organizations, even some of the small organizations have patch panel because they make your LAN network neat, and you have all the cables from different offices all packed in one small, and sometimes in a box-like device, and actually clip to different ports. So each of these cables you've seen actually is connected to a node. So we have other network devices like PoE, Ethernet over power, that's power over Ethernet. So in this case, when you have this PoE switch and injector, you can actually use a network cable to power most of these wireless devices because there are some places you go to, you don't have enough power to power some of the wireless devices, so you need a PoE switch to do that. So a cloud-based network controller. So a cloud-based network controller is a remote device used to manage network devices like access points or switches, as the case may be. So that's the work of a cloud-based network controller. So if we come down to network cables, in this video you can actually look at network cable, crimper, wireless strippers, cable connectors, punch down to network cable tester, toner, and probe. Now, these are some of the basic network tools that you need in your lab. Because if you're going to teach a student, you need to acquire this. So I would advise that we all try to get this in our labs to teach our students. So you can see the picture here of a cutter. You can see the wire strippers. You see crimpler for crimping cable. You see the ports down. The first one here is to cut, cutting cables with PVC cables. And then the second one is to actually strip this wire. Maybe probably you want to peel off the wire, you can use it. And then the crimpler is actually to clip the connector on network cable. And the punch down tool is actually used in some telephony companies for inserting the pair of wire into the RJ11 connector. So network tools and description. So here's a multimeter type of cable, multimeter for measuring current video, for measuring your current and your voltage. Remember I told us that you can measure your current, your voltage at any point in time to tell when it is actually high or low. And then we also have a tone generator to test for continuity, have a cable tester, a Wi-Fi analyzer, loop back adapter used to check port, to the functionality of that port. And then the Wi-Fi analyzer is to analyze the Wi-Fi to see if there are check the performance of the wireless network, and then gives you an insight of what is happening in the network, the traffic, the data type, the TCP, UDP. So the Wi-Fi analyzer helps to, probably in a situation where you have several Wi-Fi connections, you can actually use the Wi-Fi analyzer to analyze the topology there. So these are cable types that are common, which we'll be coming across while we begin to demonstrate this protocol. Twisted pair cable, we have the Crozier cable, like the one at the back of the DSTV dish, and the fiber optic cable, like I said, which is modern cables we have for transmitting high volume of data across the network at very high speed. And then here's the typical outlook of the Crozier cable and the different connectors for Crozier cable. And the twisted pair cable. Twisted cable will actually be shielded, and the type that is shielded, we'll have the UTP, we have the STP. So these are the different twisted pair cables that we have. And then the essence of this is that the one that is shielded is to avoid some kind of crosstalk, to avoid. So they actually are designed to suit different network design, or probably for different connection types. The essence of this is that if you're using the shielded, probably you're trying to use it in an environment where you're sure you don't want to crosstalk, where the cable can pass through the water for 1 or 2 reasons. So that actually is designed for that purpose, and it's also intuitive. Whichever different topologies you have will determine which cable type you're going to use. And then the STP, which is also better protection against your EMI, electromagnetic interference, and the radio frequency interference. And then more expensive and harder to install. Okay. So this is for twisted pair. The speed is about 100 megabits per second. And then when it's Cat 5, so we have different types of twisted pair cable. We have the Cat 5, which is category 5. The maximum speed you can get there is 100 megabits per second. But for Cat 5e, you can get 1 gig. Maybe not quite, but you can get up to 1 gig there or thereabouts. The 5e means enhanced. And then for Cat C, you can actually get 1 gigabyte at 250 megahertz. So you can see the difference, the major difference somehow between the 5e and the 6e is the frequency. And of course, frequency also plays a vital role when it comes to the speed of the network. So this is a twisted pair wire scheme. It comes in 2 formats. It's either you're looking at a T568A connector. That's network connection type. So we have 2 types. Either you're using the type A or the type B. So the type A is the T568A, and then for the type B is the T568B. And what happens here is the cable connection. So you can see in the picture to your left, that when you want to do a cable termination on your connector, the first pair of cable will be white, green, green. You can see that. The second pair will be white, orange, blue. The next set is going to be white, blue, orange. And the last two sets will be white, brown, brown. So once you terminate this cable like this, first remember you have to twist them and then align them straight and then put them inside this connector based on this color configuration. Please note this color configuration, very important. And then when it comes to the type B, which is the T568B, you see the first two pair, the first pair here is white, orange, orange. The second pair is white, blue, white, green, blue, and then white, blue, green, and white, brown, brown. Now, this is another mode of a straight through cable. So when you use this first one at the both end, it's referred to as type A straight through cable. When you use the type B at both ends, it's also referred to as B straight through cable. But when you use A at one end, B at the other end, it becomes a crossover cable connection. And so that actually, we should note down this cable colors, very important. But in the lab, when we're going to demonstrate it with our students, we actually put them right. There's a need for us to show them how to connect. The good news here is that you can actually watch this video to see how this is done. So I advise that you watch the video on your NetCard resource. So this is a lab to build a test network. So there's a need for us to build a test network. In the next class, I'll demonstrate how we could do some basic network connection using the packet tracer. I think that will also help us to have a clear idea of how the devices are connected. Here we have another cable which we'll talk a little about, which is a fiber optic cable. The fiber optic cable, you can see the internal structure of the fiber optic cable. It has a jacket, it has strengthening material, it has a buffer, it has cladding, more like a jelly-like stuff. Then it has a core, which actually is the middle one that does the transmission. So you can see the whole architecture of the fiber optic. So it uses light to transmit signals, not affected by EMI, so there's no relay frequency, there's no interference at any point in time. It passes through any electrical electrical feed environment where you're sure probably there's high voltage, whatever. It does not affect the fiber optic cable. So it's actually a good technology for this era, in the sense that so much can be done using the fiber optic. Types of fiber media, we have the single and the multi-mode. So the single mode fiber, we have the small core, we have the which uses the laser technology to send one beam of light. We have the one long distance still under the single mode. So the single mode will be small core, use laser technology to send one beam of light, and then also over a long distance. And then multi-mode. So when you're connecting two far opposite buildings, maybe perhaps sometimes over 250 meters, 500 meters, you can use a fiber to avoid losses. If you use the PVC, once it gets to 70 to 100, losses, attenuation will set in. So it's best to use fiber across long distance. And the multi-mode is actually the one you use within, probably the internal, the network. Uses LED to send light. Light is injected at different angles, cheaper. So for the multi-mode, you can use it within the network, and then the single mode for connecting far end building. And then here we have the fiber optic connectors. So we have different types of fiber optic connectors. We have the ST connectors. So it all depends on the media or the interface port you're going to connect it to. We have the ST connectors, we have the LC connector, we have the triplex multi-mode LC connector. So before you terminate the fiber cable to any of those devices, you must be sure of the port types, which also determine the fiber optic connection, or what we call the connectors. So you must look out for for the right port for each of these network, fiber optic connectors. So in summary, we explain the component types of network protocol standard and services, the purpose of device in the network, explain the characteristics of network cables, and these are all things we have discussed. So when we talk about the component types of computer networks, so that we actually looked at, which is the switch, what's the switch, what's the router, the channel or the medium of communication, types of computer networks, the LAN, the PAN, the WAN, wireless LAN, and all of that. Explain networking protocols, standard. And here we look at the different protocols under the TCP/IP model. And we look at the model from 4 layers, which is the application, the transport, the internet, and the network device. And then we also look at services that run based on the port. And it told us that these ports are actually either well-known port numbers, private port numbers, or dynamic port numbers. And so the ones that actually are assigned to well-known port numbers are some of the activities that have been happening on the network on a daily basis, where you either transfer or you receive file on the network or on the internet, and where you do a whole lot of things. So those day-to-day services actually lead to what we call well-known port numbers. And we mentioned SMTP port 25 for sending, more or less like a delivery agent, a receiver agent, we say POP, which is post office protocol, and we said this on port 110. We also went ahead to say another is the HTTP, which is port 80, then the HTTPS port 443, and then we also port 53, the DNS, and the DNS port number for DNS activity, that domain name, IP. Okay. And then so this is what, and then we also explain the characteristics of network cables, what I define network cable types. So this the different, we talked about the color configurations. We looked at the PVC cable, from straight through cables, crossover cable, and we also talked about the fiber optic cable, the coaxial cables. Now, the coaxial fiber, they all have their connectors. Even the PVC cable also have its connectors, RJ11, RJ45, and so we said that if you must configure this media component, you must make sure those connectors actually fit the right port or interface of the receiving end or the delivery end. So that at the end of the day, you're sure that you're getting the right connector for communication. So that's all what we discussed under chapter 5. And you're expected to go back to chapter 5 and read off all I've explained, and also listen to the recording to also will help you, and then be able to do the chapter 5 again. So far, I'm going to open up a question. Marilyn, are you there? Hello.
Yes, sorry, I was on mute.
Okay.
Yeah.
Question, please.
So guys, do you have any question? You can unmute and ask now. Joseph, Clement, Simon, Xavier, Jacobo, do you have any question? Hello, you are on mute. If you need to ask any question, just. I don't think they have. Hello?
Yeah, hello.
Just listen. Ah, okay. Do you have any question?
No, I don't have any question.
Okay. Anyone? Anyone wants to ask anything?
Marilyn, no question for today.
Okay, perfect. Dr. Daniel, I think it has been a very intense session today. Maybe we need to review the chapter later and go through the chapter and the recording. They don't have questions now.
So, Adams, Joseph, no question?
No question.
Okay, no question. So that means we're good, and we can write the chapter in class.
Okay.
Okay, thank you very much. Marilyn, I'm going to send all the recordings at the same time. I'm actually working on that account, like I said, so that,
Perfect. We are missing 3 and 4 by now, and this one. 1 and 2 we are okay. We received the recording.
Sure. I will make this one available.
Perfect.
We are waiting. We really need those recordings.
Sure, I will. I'll send them tonight.
Okay, thank you very much, sir.
You're welcome.
Many thanks.
So goodbye, everyone.
Bye. Thank you.